everyone. This is tutorial for Introduction to Natural Language Processing. And we have two renowned professors here with us, Professor Alexander Gelbuch and Professor Grigory Sidorov. They belong to the National System of Researchers Level 3, and they are pioneers on introducing natural language processing to Mexico. Currently, they are working at the Center for Computing Research of the National Polytechnic Institute. And they belong also to the association AMPLN, Mexican Association for Natural Language Processing. So, well, good morning, everyone. So I think this is enough introduction. Please, if at any point, at any moment you have any question, please post it at the Q&A section that you see below. If you have other comment, then you can write it to the chat box. Thank you very much and welcome. So now the screen is all yours, Professor Gelbuch, Professor Sidorov.
Thank you very much. Can you hear me? Yes. Okay, great. Thank you very much. And first of all, I would like to congratulate the organizers and all of you with incredibly excellent selection of keynote speakers. Please listen to all keynote talks. Incredibly excellent selection. Okay, and here we will give a very introductory tutorial, very introductory. If you are already an NLP researcher or student, then probably you can switch to the other tutorial. And we will mostly address people who only enter this field or think to enter it or not to enter, or are selecting their next step to study master or PhD or postdoc in this area. So it will be very much introductory. I will share now my screen. Let's try share. Okay, and now you should see my presentation. All right. Professor Grigory and myself, we will speak about Introduction to Natural Language Processing. We are from the Center for Computing Research of National Polytechnic Institute, Instituto Politécnico Nacional from Mexico. This talk is prepared with our students. We have students from so many countries that I only can here list their flags instead of a long list of names. The talk will be divided into two parts. I am Alexander Gelbuch. I will speak about main tasks of natural language processing. And then after about an hour and a half, probably, Professor Grigory Sidorov will speak about text representations. In the first part, so now we are in the first part, we will see what natural language processing does, the applications of natural language processing, a little bit of history, how we do what we do, how we do those applications. We will discuss a bit of the great danger of natural language processing. And a bit of self-advertising. I will advertise where you can study, and of course you can study with us. We both are from the city of Moscow in Russia. We both work in this computing research center. This is me. Grigory will present himself later. So I work in the National Polytechnic Institute. I'm a member of Mexican Academy of Sciences, of course, Grigory also. I am a founding member of Mexican Academy of Computing, ex-president of Mexican Society of Artificial Intelligence, Grigory also. A founding ex-president of this Mexican Society of Natural Language Processing, and an honorary professor of Amity University in India. So what natural language processing is, what the applications of natural language processing are. A fairy tale of talking machine. In fairy tales, the animals or things like this one can see, can hear, can think, can act, can talk. And we say that an animal is talking or a thing is talking to say it's intelligent. We perceive intelligence as the same as ability of talking. Of course, it's not exactly the same, but at least the ability of handling language is a very important part of an intelligent, in this case, computer. In old times like this one to the left, nowadays more like this one to the right. But anyway, talking is one of the very important abilities. In our Center for Computing Research, we have different laboratories that develop these different abilities of those magic machines. One lab to ability to see, other labs ability to reason, to move, and so on. We in our lab, we are responsible for the ability to understand language. In 2001, Space Odyssey, you probably remember the token machine handling language together with reasoning and ability to act. It was thought for 2001. And we are now in 2021. So are we any near to that machine able to understand and produce language? Well, Cortana was an attempt. Now it is practically discontinued for end users. Microsoft says it will be continued for companies. Siri is thought for this function. Well, if you try to use it, probably there is much more to be done. And still a lot already has been done, because these systems like Cortana or Siri, they are already talking machines. They handle language to some degree. We want the machines to handle language to a lot better degree, but we already have very good achievements and advances. So what applications of this science we have? Probably the one of the first and most important applications was search for information, for knowledge. Searching manually, it's impossible in nowadays amount of information. So a computer is much more capable for searching information, search and information management, for us to have even better Google, I mean, even better search engines, not just the company Google, but I believe that even the company Google, they still leverage what we as research community find and publish, make it public, I hope even our effort is in the excellence of Google search, of Bing search, and hopefully with time we will have even better search engines. Another very old application of natural language processing, probably the very first one, that appeared just when the computers appeared, with the first computers. We all speak different languages, and the computer is capable to translate from one language. This sign is very characteristic of Spanish language and this character of Mexico, translate to other languages. Machine translation is this area of research and technology. A world without language barriers. So many wars in the world are because people don't understand each other, don't trust each other, suspect each other and something bad. Now with machine translation technologies, we want to break those barriers between cultures to understand better other cultures. And hopefully this will contribute to the peace in the world. Another application, okay, in the last, well, 5,000 years at least, the main occupation of the human race is to collect knowledge, to manage knowledge, to pass knowledge to next generations. And all this knowledge is currently kept in the form of text, in books, in internet, and newspapers, and textbooks. Now, we know a lot of that. All of you are studying now in a university, but nobody programs us. We learn by ourselves from those books, just reading those texts. So now we found, as a community, we found that to program our computers, to give them that huge body of knowledge is not practical. It's too much work. We want our computers to learn on their own from those texts. This area of our science is called information extraction. For the computers to learn on their own, reading texts from internet, from books, all text available to them. Another application. Okay, look, what we had before. Such a dumb computer, and all of us, for many years, studying the language that this stupid machine can understand. Not good. Our dream is that somebody that intelligent as this guy to make once a program, maybe a very complex program, but still once, that can be copied to all computers, and we could speak with the computers in our own language, not in their language, for them to learn our language. This area of our science is called natural language interfaces. For information here, for everybody, not only for programmers. You see, this guy is not a programmer, and he has a robot home helper. To talk with that robot, this guy will talk in natural language, and in English and Spanish and Chinese. And the robot understands only special languages that machine understand. So we need a translator. We need to translate human language to computer understandable languages. And when the robot wants to reply something, then we need back translation. Of course, this translator is a part of that same robot. But now I speak about it as a separate entity because in our discipline, we study this part, this translation. And as I said, in our computer research center, other labs are responsible for other abilities of this robot. Again, natural language interfaces. Information here for everybody, including this guy who is not a programmer. Another application. We are so many people in the world. We all have our opinions, our thoughts, our feelings. A lot of information is encoded in this knowledge of each of us. And we all do speak in social networks, in comments and internet. So these voices are available. This area of our science that tries to collect this information from all of us and make sense, make use of it, is called opinion mining. Mining because it is a huge body of information where we want to find some very specific pieces of information. I will probably a bit later reason about why I call it democracy in real time. In the sense that all of us with this technology could influence the life of our countries, of our society in real time, now, here, not once in 6 years just voting for the governor. One of the important applications of this area of opinion mining is democracy in economy. The same, as I said, for us to be able to influence what's happening in economy right now in real time, to say, okay, I don't like this phone because the screen is too low resolution. Oh yes, I like this phone because its price is good. With my own voice, mind in the huge amount of information, the company will be able to adjust its products to better fit my needs, my preferences. This is democracy and economy. I would vote for this phone or against this phone, but in real time now, just saying I like it or I don't like it, and not just buying it for a huge money, or not buying it, which the company will not know even why I did not buy it. And now, as part of this application, we need to recognize emotions of the users. This is the phone. The company wants to listen to us. And to listen to us, the company detects that we speak about this phone, but now what do we say about this phone? Do we like this phone? Do we dislike this phone? Is it so surprising? Is it so bad, so infuriating? This area of our research is called sentiment analysis and emotion analysis, which serves for informed decisions, informed both for the companies to improve their products, and for us, the users. When I want to buy this phone, I want to know what others felt or said about this phone. Even more, we need to understand when others speak about this phone about what specific part of this phone they speak, because it's not enough to understand that somebody liked this phone or disliked this phone, or maybe both liked and disliked this phone. How come? Well, because the user liked the battery of this phone, but did not like the camera, and wants the memory to be improved. We need to understand of which even parts of this phone people speak. This is called aspect analysis, to understand, to detail what specifically, what part, what aspect of the object people mean when speaking about this object. Aspect analysis means detailed information for informed decisions, for democracy in real time. And this is not the whole story, because different people might like or dislike different things about those products, about a political party, can have different opinions because they're different. And to understand more specifically what people like and which people like, which people dislike something, we need to understand who they are. We need to understand whether who is speaking is a man or a woman, young or old, from what country, from what natural language, what mother tongue of this person is, what religion of this person is, many things. This large area of our research is called author profiling. The ability to read a text, read what somebody said, somebody wrote, and understand who the author is. For detailed demographics of our statistics for those informed decisions. For example, if half of the people like phones of pink color, okay, and half of the people said, no, I would never use a phone of pink color, then we have half and half. We don't learn anything. But if we understand who of them were men and who were women, we can understand who will buy a phone of pink color and who will not. Or I, as a user, I want to know the opinions of others. And if I know what men said and what women said, then I will decide for myself, is this phone good or not for me, even if for others it was good or was not good. Now, another part of this large area of our discipline, which finally leads to opinion mining, is to decide when people say truth and when they lie. Because when I say, okay, look, without technology, people can make informed decisions. People can buy right things that are good for them. People can vote for the correct political party, for the party that is good for them. Huge money is involved. Of course, there are other guys who try to cheat with this, and it is very easy to buy thousands of, a lot of positive opinions for the phone that I sell, or negative opinions against the phone that my competitors sell, or for my political party against the other political party. It's very cheap to buy false opinions. well, just asking people to lie, paying to people for lying. Now, for all this technology to work, we need to read the text, read a comment, read a tweet, and decide automatically, because it's about millions and millions of texts, to decide whether the author really thinks what they say or just lying. Veracity analysis or lie detection for reliable information. We don't only want to mine for information. We want to mine for reliable information. A similar application. You know, there are a lot of fake news now because it's very easy to produce fake news. Also with natural language processing. It is one of the dangers of natural language processing. As any powerful technology, it can be used, misused, or abused, or horribly abused. And it is very easy to horribly abuse natural language generation technology to produce fake news. And in this way, to cause people to vote for specific political party, or to buy specific products, or to make people well behave in a way that the authors of those fake news want. So with our technology, we want to develop fake news detection for reliable information in politics, in economy, in healthcare, reliable information about COVID pandemic. Nowadays, there are so many fake news about COVID pandemic, about the vaccines. Okay, we should advance another very important application. In all our system of education, of academia, the evaluation of the performance of students and researchers is based on texts they write. You know, when you're students, you are asked to write essays, to write texts, to evaluate whether you understood the subject. And for researchers, you produce research articles, you publish them, and the government decides whether to continue your salary, your funding, where to apply funding to which areas. The government decides this by evaluating your writing. And nowadays, with advent of internet, with so easy search, so easy language generation, so easy translation, it's so easy to copy. So this technology, internet plus language processing, it is killing the very basics of our education system, of our academia system, of funding of science. This is also one of great dangers that natural language processing brought. And our obligation is to mitigate this, to provide counter technology against this great danger. We call it plagiarism detection. To see text and say, no, this text is plagiarized. It is now a well-working technology with companies providing those services. At some moment, it was a research area. Actually, our team won the world competition on this. We were the best performing team at the world competition. With this technology, we re-enable 21st century education, which was endangered by natural language technology, by other technology that we also develop. We continue with applications of natural language technology. There is so much of negative things in internet, in comments. When people depend on social networks, on comments on internet, people make their decision, make their mindset reading what they read on internet, what other users generate. And there are so many bad things said in internet. Bad things attacking minorities, attacking groups of people by race, by religion, by gender, by sexual preferences. So many people attack other people. And this is reflected in horrible social conflicts. You probably know the amount of social conflicts in the United States in the previous summer, for example, with much of racist component. Here in Mexico, we had quite many problems with feminist movement, which also were caused by hostile behavior of sexists toward women, or maybe the opposite side also. In Europe, there is a lot of there are a lot of problems with migrants, with people of other religions. Now, what to do with this? Again, we should stop. We, with our technology, we should stop this. How to stop? I'm not in a position to talk about how to stop. We have government for this. We have companies with their policies. What we can do at this moment is to detect, to say, oops, this comment is racist or sexist or against sexual minorities. This area of our research has different names. Here I give the name of hate speech detection. It also can be called aggressive language detection and other names. We detect companies and probably governments. They will know what to do with it and how to stop it. With this, we contribute to promoting respect and tolerance in our society. When I say we specifically in our group, less than a year ago, we won an award from Microsoft for this research, one of 3 awards for PhD students in Latin America. So we won one of the 3 for hate speech detection research, and also an award from Google among several teams, also for our hate speech detection research. Another similar kind of applications can be, okay, let's see here, bullying detection. It's like hate speech also, like abusive language detection. Very different, depression detection and depression prediction. We work on this also. Depression detection, we read tweets by a person, well, not one person, but millions of persons. This is why automatically, and can say, oops, this guy needs medical help because he is depressive. And depression can be transformed into suicide behavior or into many bad problems. So we can detect it and alert the person, maybe the authorities. And what is more, we can predict depression. We can say, look, we analyze your tweet stream, and we see that in several months, you will have clinical depression. You should do something about it now, before it comes to suicide or something. In health monitoring, to detect emotions in how people speak, what people write, how people behave in social networks. For example, here, health monitoring for elder people who can be alone, who can have mental problems, or detect or even predict criminal activity. To say, okay, this guy in a month could become a criminal. Or in this area, there are too many negative emotions and comments, too many people unsatisfied with something. So soon, something bad will happen in this geographical area. All of this are applications of emotion analysis. And now I have spoken about it, right? When I said democracy and economy, democracy and politics. Well, democracy, it's okay, but now I'm speaking about directly saving lives. Directly saving lives, prevent suicide, for example. Some other applications of our area. I have a very long book and I want to read it in one paragraph. Or I have a lot of news, I want to know what useful information there is. In a lot of such results, what useful it is. Well, compress it for me and tell me something small. We call it text summarization. Saving, well, not lives, saving time, but saving time is also saving a bit of life. When we search in the internet, we want to know something. We want to know the answer to some question. Do all birds have wings? Who wrote Othello? Or how is the mole prepared? Mole is a Mexican food. We call this area question answering. Search for information, not for text. I don't want the text saying, okay, this bird has wings and that other also has wings. How much time will I spend filtering and reading all texts about birds having wings? Now, I want just one answer, yes or no, and maybe an example of a bird that does not have wings. So I want information that I'm looking for, not documents, not texts. And another variant of search without search. What will happen in a year? I want the program to alert me about something I need to know without even asking, or aggregate results from what is mentioned in internet. Will a certain political candidate win or not? If I just look, will Biden win? Okay, there are a lot of sides saying yes, and a lot of sides saying no. But I need statistics. So I need just a binary decision, but with well-done statistics. This is called text mining. To know what I need to know without even searching, without even a query string and analyzing myself a lot of document that Google found. Another application. Okay, in a lot of texts, like in this case, medical records, then I need to analyze those medical records and understand the relationships between drugs and diseases. If a patient was prescribed this drug, will that patient in 3 years have this disease? It's like also like mining that I mentioned in the previous slide, but in very specific kind of texts and with very specific research questions. We call it clinical records analysis. A lot of clinical records like this to convert it in medical knowledge. In our lab, we also have worked on it quite a bit. Again, saving lives, directly saving lives. Another application in which we worked quite a lot, legal informatics, to be able to reason about laws automatically by analyzing a huge body of already existing legal decisions, or already existing court records. This will bring equal justice for all. An automatic lawyer will be cheap for anybody to use. You know, lawyers are extremely expensive, but an automatic lawyer is cheap. And it will be equal justice because the automatic lawyer will behave in the same manner for everybody without preferences. Finally, okay, we have a lot of applications. I just mentioned those on which we have worked in our lab. Even we have worked on music generation. Do you think music is a language? We could generate music using natural language generation technology. Just so much fun to use language generation and make it music. Okay, there are a lot more applications, but I need to continue. A little bit of history. Our science, which is also called not only natural language processing, we also call it computational linguistics. Actually, under this name, it appeared about 70 years ago, under the name of computational linguistics. So about 70 probably years ago, with first computers, computational linguistics was an area of linguistics with a lot of linguists writing the rules, dictionaries, grammars, which computers of those times could understand. Then, about 20 years ago now, With the advent of internet, our area, computational linguistics, or it became to be called natural language processing, it was turned into an area of machine learning. You know what machine learning is. I will not describe it now, but from so many texts in internet, we could apply machine learning techniques and make machines of those times to learn from the texts on their own without those linguists writing lots of grammars and dictionaries and saving the effort of those linguists. This, to me, it looks like magic. I am still from pre-machine learning times. And for me, it looks like magic. Information appears from nothing. I don't program the computer, but the computer still learns and behaves as if it is programmed to understand natural language. For me, it was very shocking. Probably for you, it's nothing now, but I'm from those times. And nowadays, with deep learning revolution, things changed very much with the advent of deep learning. And now natural language processing, now a few people speak about computational linguistics. Now our area, natural language processing, is an area of deep learning. Practically, most of the publications on natural language processing are now publications on deep learning architectures. With deep learning, the computer acts as human brain. Not exactly, of course, but with the ideas underlying human brains. And probably this is why it works so incredibly well, because language is designed for our brains. Now, if we give that brain to a computer, it will also understand our language. What's next? I think a combination. Actually, I think we cannot rely only on deep learning, even in the ecological sense, because deep learning is so energy consuming that it becomes bad for our planet, bad for our ecological resources. But of course, we will not return to just writing grammars for the computers. So there should be some combination. When you come to this area and do your master's and PhD and postdoc and your research in this area, I think you will work on some combination of the two ideas. Symbolic approach and neural approach. Some trends, historical trends in natural language processing, maybe not that relevant for you, but I saw our science in those changes. A great change from art to technology. We now have ready tools. You can just download tools and they work. You don't need to understand the underlying technology behind every tool. You just download it. Great change from just a few examples to mining in a lot of data, going big data, going social, a change from analyzing books probably to a huge body of social networks, social internet, and going emotions, going from semantics, from understanding what the text says, to analyzing emotions in the text. Why emotions? Look, how many people speak about ideas, speak in grammatically correct language, and how many people just say, hi, I'm so happy today, or I'm frightened today because something happened. Look, even apes can express emotions. A lot of users, internet users, express emotions, and very few write books. So this is the way to big data, from semantics, from books, to emotions. Hello, I'm happy, I'm upset. Frankly, a lot of what is said in social networks, in internet comments, frankly, I don't see more meaning in it than I'm happy, I'm upset. I like, I don't like. So this is huge data. Going multilingual, going from English to all languages, to minor languages, to major languages that we don't even know they exist. Don't know about Malay language. Okay, and there are, I think, like 4 times more speakers of Malay language than people in Mexico. Okay, even bigger data. And finally, going industrial, going commercial. In old times, we were poor academics. And suddenly we became rich. Suddenly, huge companies like Google, Microsoft, Apple, Amazon are very much interested in natural language technology and see natural language technology as their priority development directions. So suddenly there is huge money in this area. Just one more reason for you to come to this area. We are not already just poor academics like mathematicians. We are rich. And let's see how much time I will have for this, but a bit of how we do, how these technologies behind those applications. Usually our technology is structured in a lot of smaller tasks. Here I show the suitcase of sentiment analysis. You see, we start from microtest normalization and sentence boundary detection, disambiguation, and many things will happen until we can arrive at aspect extraction. I have mentioned it, polarity detection, which means good or bad, and come to really problem solved, to detect the sentiment behind some text. So a lot of small things. As an example of opinion mining, why I'm talking so much about opinion mining? Well, of course, because we in this lab work in opinion mining, among other areas. I have a dream, a world where we can listen to others, to all of them, and where all of them could listen to me, for me to be heard. Why? For businesses, it will mean understanding. Understanding what their clients think about, their products, their services, and understanding means improvement and means better income for businesses, for companies, and better salary for us. For us, the end users, the ability to understand and choose, understand what all of them liked or disliked, and choose better products, to buy better phones, to stay in better hotels, to vote for a better political party. For the government, it is a way towards improved, towards informed government, a government that would know our needs at all levels, at the global level, what the whole country thinks, or at a very local level. If there is no light in my street, okay, it's too dark, I want the government to put lights in my street. If the government does it, I will vote for this government, good government, it did it. How can the government know my needs, my personal, I mean, not of all people, my personal here on this street, in this building, by what I say in Twitter, in comments. I will not go to the governmental site and leave a complaint. No, too complicated. I will just mention it in Twitter. This government will be informed. It will gain my vote and will do what I need for me to be happy. If it puts the lights on my street, oh, I'm happy. Good government, good for me. This is what I call democracy in real time, because if I need a government that would repair the road in front of my windows or put a light on my street, well, first I will wait 6 years. Then I will vote for a political party which promised to address the needs of who knows whom. And then I will vote other 6 years because it will not do what it promised, or it just does not know that I need it. And so I will exercise my right for democracy once every 6 years, and only binary, voting for this party or against this party. Without technologies of opinion mining, I just leave a tweet, then some programs collect the information, inform the government, and it changes its behavior. It does what I need now, here. This is democracy, because my opinion, my vote now, here at this moment, influences the life of our society, the actions of our government. As a principal part of opinion mining, I mentioned already sentiment analysis. Opinion mining is 2 steps. Analyze each one of the documents, make a database of it, and then mine in this database. I'm not speaking about the mining step, I'm speaking about analysis step. So I have one document and want to convert it into a table, into a database. So for each document, I want to know what it says, whether the author is happy about what they are speaking about, unhappy. I already mentioned polarity detection, like or dislike. There is a very big technology behind it. It's not easy at all, because people don't say, I bought this phone and it is a good phone. No, people don't say it in these words. They can say, I bought this phone and the duration of the battery is much better, or the battery works for a longer time. And then I should guess automatically, is it good or bad? What about specifically? I already talked about it. So this phone, I like something about it and don't like something else. I like the resolution of the screen and I don't like the camera. So the mining program should understand what aspect of this phone is good or bad, what I'm speaking about. Next, I already talked about it. Who is speaking? Who is speaking? Because if half of the user says, say this is good, half say this is bad, it's very important to understand who they are. Gender. Okay, I will not buy a phone of pink color, but half of the human race will buy it. Age. This hotel is so good with live music until morning. It's probably okay for young people, but I would not go to that hotel with my age. Religion. Do people like ham, pork? Well, you can find comment that, well, pork is so good. The word spam is from pork, you know, P in spam is pork. Okay, so many people like pork, and so many people don't like pork and will never eat pork. Why? Both speak English, but some of them speak English in Canada, and some of them speak English in Pakistan. And in Pakistan, because of their religion, if I detect their religion, I will know I should not sell them pork. But yes, I can sell pork in Canada. Again, real, because huge money is involved, and it is so common that companies or political parties buy opinion or falsify opinions. So I need to guess whether the opinion is real. When the opinion was given, or about what time it speaks. If now I analyze opinions about Trump, probably it is not relevant already. Where from? As I said, from Canada or from Pakistan, then I will know where to sell pork, where not. My products or and many more things I will want to know by a very small text, by a tweet. And I should guess all those texts, all those kinds of information automatically by a tweet. So how? A classic approach. Language as a protocol of data transmission between different people or people and machines. It has complex structure at many levels: word sentences, semantics, pragmatics, syntax. Now, what is the structure of this protocol? And the goal of this classic approach is language understanding. Just an example. This is an opinion. The car is old and expensive. Okay, old is bad, expensive is bad, so bad. Okay, we understood. This car is very old, but it is rather not expensive. Well, keywords: old, expensive, no, bad. Oops, we did not understand it well. So let's go and find the structure of this sentence. There is a technology behind it called syntactic parsing and many other things developed over many decades. And according to this structure, we will process this sentence in some structured way. Here I show it like an electronic circuit. And finally, we will get, oh, it's rather positive recommendation. So now we understood it. Okay, great. So in a classical question, what protocol did God create for people to interchange information? This structured protocol, we as a community, we studied this for 50 years to translate from text to the meaning representation for computers. And the modern answer is, I don't want to say who cares, but we call it end-to-end applications. We take the text, then some magic happens, and we get the final answer. This magic, you already guess, it is called deep learning or machine learning before deep learning. So nowadays, deep learning is what we all are involved in. When we do deep learning, what we should care about? The most important part of it is to choose the right architecture. The research is in choosing architecture. You see here, there is a complex architecture, not the same as here, just many layers and that's all. No, they are organized in a complex way. Next, data. Usually neural architectures are supervised learning. So we need to prepare right kind of data. A lot of our activity is devoted to develop data sets. And often we need to label them manually, probably not I myself, but then I should organize a team of people manually labeling data sets. And finally, optimization of the learning process. A good news is that there are a lot of radial libraries. Do you remember I said at some moment, okay, we are not already art, we are technology. So you can just download ready things. In Python, I liked PyTorch library. It's very simple. There is TensorFlow library, Theano library. So there are libraries where you can just download the library, learn a very simple programming language, interface of this library, and today, just now, build your first deep learning application. When you develop deep learning, what issues should you care about? What to feed as input, what network architecture to use, how to classify, how to combine different types of features, how to take into account the wider context of a small piece of text that you are working with, how to combine deep learning with other linguistic approaches, and how to combine different classification types. I will show what worked for us. I will try to go faster because time is running. Actually, I think, Grigory, you can just shut me up when you decide it's enough. Okay, meanwhile, I will continue while Grigory doesn't shut me up. So what worked in our lab? What feed as input? Look, we cannot work with letter strings, at least not with the technology we have now. We are much better working with numbers, actually with vectors of numbers. Grigory will speak about it. And we choose vectors to keep important properties. So this part is called word embeddings. We take words and we want to convert them into numerical vectors. The keywords that you should know Word2Vec is a way of doing this, to convert words to vectors. You can just download it. You don't need to do it yourself. A dictionary in 2 columns, word and its vector. Glove is a better way of doing the same. And BERT is the most recent way of doing the same again, but very resource consuming. We have very hard times working with BERT in our lab because the servers to which we have access are not always capable enough to handle BERT as embeddings. The idea behind BERT embeddings is simple. Okay, look, you can convert words into vector just in this way. Just for a word cat, take a vector with 1 here and zeros others. And the vector of 100,000 coordinates is enough to represent all words, but it doesn't keep important properties of the words. It doesn't help. So what we want is to combine those vectors into much smaller but much more informative vectors. So there is some technology. This picture is from Word2Vec method, some magic happening there, which I will not describe. And here it is. Vectors here, I show 2 coordinates, but in fact it's 300 coordinates. Well, look, these points correspond to words. And similar words are mapped into close points of the space. King is here and queen is here. Obviously, king and queen are in some way similar. Now, relationships. Look, the difference between king and man is the same as between queen and woman. Actually, it's well, being the ruler. So this arrow represents being a ruler. Adding this being a ruler to a man, we obtain king. And many other relationships are kept when the words are converted into vectors in a good way, in the right way. As I said, BERT is the perfect way to do it at this moment, but very expensive. Next, what network architecture to use? Well, a deep neural network looks more or less like this. Many layers interconnected in some ways. I cannot now speak about what a neural network is. So in a way, to classify, many of our tasks are classification tasks, good or bad, like, dislike. To classify is, in a way, to compress to 1 bit, good, bad. So a neural network looks like compression from a lot of things into just 1 bit. It discovers the important features level by level. Low-level features, combining low-level features, it discovers higher-level features. Please read about deep learning. I cannot speak about it now. I will only mention keywords that you need to know. Convolutional neural networks. It's a very good idea when neural networks share the parameters. So you don't need so many different parameters to optimize. Just remember this keyword, convolutional neural network. It does something that looks similar to traditional Engrams models. Grigori will speak about Engrams. Now, text is a sequence. This makes it different from images. Neural networks are also used in image analysis, but what we here have and they there don't have so clearly, they there in image analysis, is sequential representation of the data. So when you read the data one by one, this is utterance 1, utterance 2, utterance n. You need a memory. You need to remember what was said before. Just remember these keywords, LSTM, long short time memory, GRU. Just remember these keywords, kinds of memory, kinds of way to remember what was said before the utterance, the piece of text that you are analyzing now. Then remember this keyword, attention. Here I show attention matrix. It means that when we analyzed utterance number 7, sentence, okay, let it be sentence. Sentence number 7 in a long text, it said, oops, what was especially important here to decide the emotion behind this text was audio, because we analyzed a video clip with facial expressions, the sound of speaking and the meaning. So it said, oops, no, it was not audio, it was video. Okay, facial expression was very important here. But text was very important when we analyzed utterance number 4. This is how it works in images. The system is generating a text. A woman is throwing a frisbee in a park. And here is where the system looks when generating the word frisbee. Somewhere here, there is something that helps the system to decide on the correct word. This is called attention mechanism. And the very recent and most important at this moment technology in deep learning is called transformer. In transformer, you practically use only attention. You don't use memories, but you model what previously we modeled with memories. You model with attention in a much better way, because attention works in a much better, much more efficient way than memories. The very paper that introduced the transformer model has the title, Attention is All You Need, in the sense that on attentions, you can model what previously we did with memories. This is the best of neural architectures so far. Hopefully, when you come, you will invent something better. How to classify? Of course, the network will classify on itself, but we, for example, used a different way. We trained a network, extracted features from its penultimate layer, and used a classical classifier on these extracted features. Neural network as feature extractor. And of course, there are many different other ways to classify. How to combine different types of features? This is feature fusion. I will skip this slide. Feature fusion, when you have different types of features, you can combine them in different ways. Here, you have different sentences, sentence 1, sentence 2. Then, in our work, we did not just concatenate the vectors. No, we process them in some number of layers separately, each sentence. Then we combine them, and then we process them together. When we worked with video clips, multi-modal sentiment analysis, or not necessarily sentiment, of course, but we worked on sentiment. When our language is, as language should be, multimodal, speaking, using words and using facial expressions. You see here the person is happy. So we have facial expressions, the pitch of the voice, and the meaning of what the person says. How to combine the three kinds of information, very different information. We can just concatenate them and build a network over those long vectors. Or we can combine two of them and build a network. Similarly, we can process them during some number of layers separately, then combine. Or we can combine them in a complex way, in a hierarchical way. And recently we found that even a more complicated way gives better results. This is an example of how we develop our architectures. That an architecture is not just the same layers repeated several times. How to take into account the wider context. So we extract text, words. We used convolutional neural network for this. We extract video. We extract audio from the video clip. Then we combine them somehow. And we, in that time, we used memories. Do you remember this? LSTM, long short time memory. We use memory to take into account the context when we process this utterance sentence. We remember what happened in previous utterances. This is what I call architectures, not just several layers. Here, where we injected global features for a document, not extracted from any one of the sentences. For example, the number of sentences, number of verbs, number of nouns in this document. You cannot extract it from just one sentence. So we process the sentences, and then we added here, this small piece is the additional features. And then we continued processing. How to combine deep learning with linguistic approaches. Grigory will speak about syntactic engrams. Text has a meaningful structure, and you can convert that structure into numbers. This is also called embedding, but other structures, embedding of other structures. Here, a sentence. I clearly see there a very nice little girl playing with her toys. And this is a structure of the sentence. We have technology to build this structure. The situation is seeing. I see something. Who sees? I. How? Clearly. Where? There. Who? Go. Of. Which go? A. With what properties? Nice. Doing what? Playing. Okay, playing. Now more details. Playing with what? And so on. So we can extract what Grigory will call bigrams. Actually, Grigory invented this way of embedding. See and go. Look, these two words are not next to each other in the sentence, but they're next to each other in the structure of that sentence. This is 4 gram. This is 5 gram. In the structure of that sentence, a small subtree in this structure. Then we combine those, the embeddings of those Engrams with word embeddings from the other technologies. How to combine different classification types. Okay, here I will just mention multitask learning. It worked quite well in a number of our experiments. When you know for the same data set, you know different types of information. Of course, you can train 3 different classifiers. It will work. But what works better is to train them up to some number of layers together, and only then separate them into separate layers and have separate output layers. So we applied it in different situations. For example, in detection sarcasm, together with emotion. We had a data set labeled both in sarcasm and in emotion. Sarcasm is a linguistic phenomenon, very important because it's very frequent when people say just the opposite to what they really mean. What a good phone. It broke the next day I bought it. Well, you all understand what I want to say. The phone is bad. But for a computer to understand that it's really bad, it's quite challenging because I directly say that it is good. It's very difficult to detect, but it is very important to detect because people use this linguistic device very frequently, and it influences very much to our classification results. So we had the corpus both labeled both with polarity, good, bad, and sarcasm. And multitask learning worked very good for us. Now we are okay. We are nearly at the end of my part of the presentation, but I wanted to mention something that is not commonly discussed, and I feel it very important. As I said, our natural language technology can be extremely dangerous. Why? Okay, first, it is an artificial intelligence technique. All of you have heard about artificial intelligence weapons, intelligent weapons, and how horrible they are, how dangerous they are. But information is also a deadly weapon. Information is a very powerful weapon also. The fact that someone knows everything about each one of us, you remember our technology permits to know your age, gender, religion, native language, a lot of things about you. Author profiling, you remember. And that somebody has this information about each one of us is extremely dangerous. Now a question. Okay, do you think this monster intelligent weapon can it destroy the European Union? Do you think it can destroy European Union? Well, probably no. It's very dangerous, but probably European Union has its own missiles and its own weapons. The key word here is own. Own means controlled by them. against this weapon controlled by bad guys. Okay, so probably they can defend themselves. But this guy can. This guy can destroy European Union. This is Robert Mercer, famous researcher in artificial intelligence and in natural language processing, who won the most important award in natural language processing, ACL Lifetime Award. How he can destroy European Union? Well, he is an American, and European Union is an economic rival of the United States. So what he did, Robert Mercer, he analyzed the Facebook profiles of all British citizens. Facebook is an American company, so no problem on this, in the access to Facebook profiles. So he knew everything about every British citizen. Why? Look, Facebook is an American company. Do you remember I mentioned European Union has missiles controlled by them, but they don't control Facebook. So Robert Mercer, he had all the information about all British citizens. Next, he built custom messages, different for every British citizen, different, saying something that will convince this specific citizen, depending on their religion, age, whatever, which will convince that Brexit is good for him. It's good for young people because blah, blah. It's good for old people because blah, blah. It's good for Muslims because blah, blah. You can convince each one with different arguments. Then Brexit. Brexit is, well, in some very important part, it means destroying European Union. And it's just first step. So look, sentiment analysis and author profiling in social media were used to destroy the European Union. Worse than bombing could destroy it. Bombing could not destroy it because they have their own missiles controlled by them. But social networks and information technology is not controlled by them. And now who's next? Frexit, Spexit, your country. Who's next will be under manipulation from those who control this technology. So understanding social media gives enormous power over the world. If one knows your gender, age, language, religion, knows what you like, what you dislike, what you think, what psychological traits you have, then they will know what you will buy, what you will, how you will vote, what you will believe in, how to convince you in whatever they want, how to manipulate you, how to control you. And now the only question is who controls those extremely powerful technologies. So who controls them are about 3 companies from one country in the world. They control all our virtual world. All that I know it because those 3 companies wanted me to know it. Google, Facebook, Twitter. I don't watch TV. I don't have a TV set at home. I don't read newspapers. Frankly speaking, I don't have time for this. So whatever I know because Google decided that I should know it. I call it Googleocracy. Do you remember the movie, The Matrix, where people lived in an artificial virtual world created by a computer? I'm not sure how far we now are from that setting, because I live in a world which Google and Facebook and Twitter decided is good for me. Search engines and social networks are monopolies, and monopolies of one single country. Now, do we live in a virtual world when we think that Biden or Putin exist? Do they really exist? Or did Google invented them? I don't know. I know about them. Whatever I know about them, I know from YouTube. I watch YouTube for news. So I know only what Google wants me to know. And with current technology, with deep learning technology, it's very simple to generate videos of very high quality that would tell you whatever. So I don't know if Biden exists. Virtual society. Now Facebook can generate what friends we will have. This was used in Brexit manipulation. We spoke about fake news detection. Of course, fake news are very bad, and detecting fake news is very good. But now, how do you know that this news is really false? Who decided that it was false? Who controls the technology? Who will decide, which news are good for us and which news we should think that they are false? We will be told that they are false. Who decides? You remember what happened to Trump? The president of the most important country in the world, he was just, well, turned off from our virtual world by three private companies. And we speak so much about democracy. Democracy is based on decisions. Decisions are based on knowledge. My right on democracy is based on my knowledge. I will vote for the party of which I know it is good. And whatever I know because three companies in the world want me to know this, or to suppose this, to think this. Well, quite horrible. How can we defend ourselves from outside manipulation? I see two ways: breaking the monopoly, developing our own technologies, our own Facebook, own Google, own Twitter. China and Russia already chose this way. For good or for bad, successfully or not, it's not trivial. It's not that trivial. If we here in Mexico decide to build our own Facebook, imagine, it will not work. In China, it could work just by size. In Russia, by different considerations. But still, well, it's one way that we could consider. And second thing, we can counterfight understanding. Any manipulation fails as soon as you understand that you are manipulated and you understand how you are manipulated. Then they will not manipulate you. So studying natural language processing, studying it here, not waiting for them to develop the technologies, not being just importer of technology. You becoming an expert in natural language processing is a way to counter the dangers and, of course, to leverage those very good applications of which I spoke so much in the first part of my my talk. So, are you excited by great applications of NLP? Or are you dreaded by its great dangers? Same answer for both cases. Come and study it. Become part of it, understand it, contribute to it, influence to its development. Now, next question, of course, where to study. In Mexico, we have very good NLP teams. NLP is natural language processing, you know. In the UNAM, a group of led by Gerardo Sierra. In AOE, a group led by Manuel Montes and Luis Villaseñor. In YM, a group led by Yulia Ledinova, our graduate of our team, also Manuel Montes as our graduate. In Guanajuato, Rafael Guzman, and finally, I can mention our group, the Center of Computing Research of Natural Polytechnic Institute, a group led by Grigori and myself. Of course, I know more details about my group, so I will give a bit more details. It is the first NLP team in Mexico and one of the first in Latin America, if not the first. We can give very attractive scholarships for masters and PhD. Not only we, probably other groups also. I don't know really. Surely Gerardo can. We have students from many, many countries, from all continents. We have won many national and quite a number of international awards from Microsoft and Google, which I already mentioned. This is our website. Look, it is NLP of Natural Language Processing. Then CIC of the abbreviation of our school, Centro de Investigación en Computación, of IPN, Instituto Politécnico Nacional of Mexico. Okay, or you can just search by my last name. It's not very common. You will immediately find our group. You see, we have students from so many countries. This is our website. And this is a small part of our team visiting Bloomberg office in Mexico City. And I showed the flags, of course, Mexico, and Bangladesh, Pakistan, Russia. Well, I'm from Russia, as I already mentioned, and Pakistan, India, Vietnam, and many more. At that moment, we did not have all the team in that office. More information in our publications, of course. You can just Google for my name and find our publications. More information about our scholarships. Google for my name and look for scholarships announcement. We now have an open call for masters and PhD. Contact us now, or just read here the information. Contact us now, and we will help you to apply for Masters of PhD or PhD scholarship. And thank you. Not sure if we have time for questions. Probably we should postpone questions to after Grigori's part. Is it okay?
Some questions, but I don't know how long it would be the section of Professor Sidorov. We have about two or three questions. Maybe we can answer quickly. I don't know.
Okay, if 2 or 3, yes, let's handle them now.
Okay, there are some questions and comments. First of all, Jessica Sarai Mendez asks, are there applications such as Jana so that there is a kind of chatbot to accompany and detect emotions? And as they say, the government must use them as tools to give support. Is there a country that has really used these tools to support citizens and that would have been a success story?
I did not understand that about government. What about government?
To use tools, chatbots to give support, I mean in a positive way instead of negative things as
Okay.
we saw in the talk.
Okay, I didn't quite understand about the government, but chatbots, I did not mention it here as many other technologies. I could not mention everything, but yes, it is a huge research area. Yes, it is. Sometimes it is success stories. We in our team work quite a lot about those technologies, specifically about empathetic interfaces, exactly what you mentioned, to share emotions, to understand psychological type of the person. Yes, it is a big research area, and we have published in it. Now, is it success story? At some moment it will be. My feeling is that with the hype of those interfaces, there are too many companies and governmental offices who try to imitate cheap conversational agents that actually don't show any intelligence. If somebody of you remember the Clippy of the old Office, Microsoft Office, if you remember the Clippy, an extremely annoying agent that popped up every minute and asked, oh, do you want help here? And I can help you there. Or I'm here, hi. Extremely annoying. My personal feeling is that now this technology or lack of technology is too much abused, and too many pages and companies and government pages, sites abuse cheap, not intelligent conversational agents, which is very annoying. I never use them. I always try to, if I cannot turn it off, just hide it with another window for it not to annoy me with constant moving, because they tend to constantly say, I'm here, I can help you. Hi, I'm here. I think this is very bad. But the technology is being improved, and our conversational agents are being are progressing. They're better and better with time. In Mexico, there is a very good company called Yellow Chat. Our graduate, who was a student in our lab, Ivan Cruz, is the head of artificial intelligence department of that company. It's a very serious company that produces serious interfaces. We collaborate with a lab in Singapore that produces very serious emotional interfaces. But they are expensive, complex. This is why this idea is so much abused. Well.
Okay, thank you very much. We have a raised hand by Enrique Mesa. Would you like to pose your question, Enrique, please?
We can also enable the audio for Enrique if you want, Hiram.
Yeah, he's allowed now, so if maybe he can unmute himself.
I think we should ask Grigory if if he wants us to continue with the questions or wants to start his talk. Gregory, hi.
This is a question.
Please go on, because I actually was mistaken in raising my hand. So I have no question.
Oh,
Okay,
great.
so no questions.
Good news.
Okay, so maybe there are some general questions that could be answered at the end, because these are related to pursuing the NLP career and also of other groups in Brazil. So I think this is very interesting to answer. Maybe we can answer them after Professor Grigory's intervention.
Okay, so shall I start? So please confirm.
The questions are also available in the Q&A section here, Alexander. So if you want to type your answer in the meanwhile, Grigory starts his presentation.
Type answer in chat.
Yes.
Okay, I will try.
Okay, so thank you. Please confirm how much time do I have until 1:30 or more time?
Yeah, it should be 1:30, and if you want to have some time for answering a few questions, maybe 5-10 minutes before.
Restrictions. Okay, great. So let's continue the presentation. It would be more technical, I guess. So I guess Professor Gelbuch already told you about the possibilities to study in our center. We have a nice group, and if you are interested in other computational areas, you are also welcome. You can visit our website. So first of all, I will discuss what we will not see at my presentation, but as you can imagine, if I mention these things, then these things are really important. So I recommend you to study them by your own. And I guess that if you can manage all these, yes, you will be very proficient in natural language processing. And in this talk, we will speak about some general concepts that you should understand. Well, if you can apply some technical libraries, it's fine, but you should understand what are you doing, what for, what is going on. So this is the idea of my presentation. So what is going on really? Okay. So we will not speak about machine learning algorithms here. Well, you guess naive Bayes, support vector machines, logistic regression, random forest, other boost, and there are many other algorithms. So we will not learn here Python programming. Well, for some reason, Python is very popular in natural language processing. It is really very simple language. So if you know any other programming language, it would be really easy for you to learn Python. The great advantage of Python is that there are a lot of libraries for any task related with machine learning or natural language processing, practically any task, you can find a library, which is a very good idea. And it is really easy to apply the libraries to your tasks. Okay. And there are, well, as I mentioned, many libraries. So machine learning libraries. Well, traditional machine learning is scikit-learn library. So you should learn it, certainly. You should know it. Well, just few lines of code, and you can perform experiments using natural language processing. So you should formulate your problem, and you can have your data, and you can apply this library. This is traditional machine learning, okay? And also there are various deep learning libraries. Alexander mentioned PyTorch. Well, here I will mention TensorFlow, well, TensorFlow by Google. And well, I would like to mention Keras. So you can learn TensorFlow, which is not really very difficult, but somehow difficult. But you can use Keras, which is built over TensorFlow. Well, you can also use Tano for this as well. And using Keras, just one line of Keras program code in Python will correspond to a to construction of the neural network. Yes. So very, very easy. So there are some other useful libraries for natural language processing. I would like to mention GenSim library. For example, it implements several LCA, LDA, word-to-vec method, and so on. And it also has word-to-vec, GLAV, and fastText as resources. Okay. And there are several natural language processing libraries. I would like to mention Spacey, Stanza, and NLTK. Well, you can have all of them installed. Well, probably the basic and most well-known library is NLTK, but probably it is not so real-world library. It's more like for studying natural language processing, right? For example, they say that Spacey is 400 times faster than NLTK, okay? And also the recently appeared Stanza library. Stanza is developed in Stanford. For example, one of the speakers at this school is Christopher Manning. So he is one of the creators of this Stanza library. It is, well, what draws our attention in Stanza is that it is neural based. So it uses the most advanced technologies. It is implemented for, well, it was implemented recently for 66 languages. I don't know if there appeared more languages, but yes, all major languages are there, so you can use it. As far as I understand, Spacey is for English only, okay. And also, so just learn to use them. There are tutorials. It is really simple. You just create pipeline. Pipeline is a sequence of modules you will use. There are standard pipelines, and you just apply them to texts, and you will get some output. So you should just understand what is your input, what will be your output, and what will you do with your output. Okay. And we will not discuss, well, in detail the ideas of deep learning as modern stage of artificial intelligence is deep learning. So like attention mechanism, transformers, convolutions. Well, Professor Gelbuch spoke a little bit about this. So, well, I will also mention some examples if I have time. So what we will talk about, well, it's just introduction, vector space model. We will discuss what types of features, what types of values, what is the general processing scheme if you want to apply machine learning in natural language processing. And this is our modern paradigm. We apply machine learning to natural language processing to texts. So, and I will try to show you how to do it, okay? Well, probably the rest of my agenda I will not have time to discuss. No. But I would like you to recommend my book, Syntactic Engrams in Computational Linguistics. The first part of this book is the introduction, so it is pretty much what I will talk about today. So if I will not have time or you have some doubts, you can just contact, well, just read this book. I have also the previous version of this book in Spanish. The Spanish version of this book is called Construcción no lineal de enegramas en lingüística computacional, and you can download it from my webpage. So, okay. If you have some problems of getting this book, you can contact me, for example, in ResearchGate, and we will see what can be done. Okay. Okay. So first of all, one very philosophical, maybe philosophical question. So all of you, I guess, have some general idea what machine learning can do. So what computers can do in general, or if you prefer, what machine learning can do. Just in one word, how we can discuss it. Describe it. How we can describe it? Well, in general, obviously, it can calculate some numbers. 2 plus 2 is 4. Okay. It can manage some databases storage, no problem. It can apply algorithms. Algorithm is a set of concrete instructions, just step by step. So if we can give these orders to our computer, the computer will be able to execute it. Great. And now not so exact calculations, which are called heuristics. So for example, bio-inspired algorithms are heuristics. So if I cannot solve my problem, what shall I do? If it takes too much time to process my data, for example, if it is NP-complete problem, well, it turns out that artificial intelligence allows us to solve NP-complete problems, well, very specific NP-complete problems, which we can formulate as NP-complete problem using bio-inspired algorithms like genetic algorithms. So if we can formulate it, then we can solve it. Okay, so these are the things that computers can do. But what shall we do in case of language or vision? Can we just invent some genetic algorithm? Well, no, we should have clear formulation for genetic algorithm. Is it just multiplication? No. So what shall we do? Well, I ask my students, and usually they doubt. And well, in fact, it is the same problem. What is machine learning about? Well, we can say computers can apply machine learning. Okay, great. So what is machine learning about? Just 1-2 words. So how will you define it? Well, 5 seconds to think. Everybody knows the answer. Okay, what is machine learning about? One phrase. Well, the computers calculate similarity. It is not so intuitive, maybe a little bit unexpected, but the key word here for machine learning is similarity. So if I want to, I don't know, recognize a scene, well, my main question will be, this scene is similar to what scene I know before? Yes, so similarity. If I want to understand the language, I don't know what is understanding of the language, but I should somehow calculate similarities with what I already know, and then I will understand the new information. Okay, so machine learning is about similarity of objects. It will be specifically more clear if we will talk about machine learning as classification problem. So classification, I have 2 classes of objects, for example, 2 classes, there can be more. I have 2 classes of objects. A new object comes. So my question is, to what class does it belong? And in fact, my question is, to objects of what class this object is more similar? So similarity, yes. And so the next of my talk is how to calculate similarity of objects for informal manner for computers. So how to calculate similarity. Okay, well, just first some also general ideas about artificial intelligence. So will it dominate the world? Well, Alexander says that yes, soon we will all be manipulated. Well, I hope that, well, maybe, well, in fact, this manipulation idea exists from old times. Yes, we can see some films where the bad guys would say, please prepare the public opinion for this bad news. Well, this prepare the public opinion means there will appear some publications in the newspapers and the public will accept as the truth something that might not be the truth. Yes. So, but the idea of manipulation exists from the very old times. Okay. And the other idea, non-trivial computing is artificial intelligence. Yes, in fact, it's the common situation. And speaking about artificial intelligence, well, my vision is that it started with reasoning since the 80s. Then the focus of attention was posed on knowledge-based systems. It seems very easy. Just to extract the knowledge from the expert, and we will be very happy. Well, it turns out that manual extraction is too expensive, the knowledge is too complex, and so the idea, say, of expert systems, well, there were some working expert systems, but the humanity was not so happy with them, okay? So the other idea was the heuristic algorithm, like bio-inspired algorithms, and yes, they are very useful, but they can solve just some specific tasks which we can formulate as such. Okay? And then the era of machine learning, or also the other term is big data. Is the same. Machine learning and big data is practically the same. When we say big data, we make our focus on the data, okay, as such. So machine learning was the focus of attention. And of course, the important part of machine learning was deep learning. So why now? Well, I think that the main reason why it is so popular, well, it can solve many problems. And now the hardware is finally suitable for applying these deep learning algorithms. The algorithms existed before, but we were not able to apply them. Now we can solve this. One more consideration is that, yes, we should apply deep learning in natural language processing and image processing, but probably some other data processing problems we shouldn't try to solve using deep learning, because traditional methods may work better. Okay, but yes, we should try. So another consideration is that our science is empirical. So we can build some theories, but to prove them, we should make experiments. And experiments will show who is right and who is wrong. Okay. So now how? We want to calculate similarity. So there are objects in the world. So it can be any object. It can be human beings, or it can be books, it can be texts. Books as physical objects. It can be texts. Yes. So all these objects will have features. So the human beings can have age, right? They can have weight, they can have height. So these will be features. So I can characterize a human being in these terms, okay? And these features will have values. So my age is 55, okay, great. So, and I can compare myself with other human beings. So objects have features, features have values. And so finally, instead of objects, what do I have? I have vectors of feature values. So any object is vector of feature values. For example, if I'm speaking about human beings, I will take age, height, and weight as my features. I will have a vector of three dimensions, which can characterize any human being. And then I can see which human beings are more similar to each other. Okay. So finally, when I convert my very complex objects to these vectors, I built a model. Yes. So this is a model. What science do? Any science builds models of its object of study. So now I'm constructing my models for my objects. So the question, is this model objective or subjective? Well, 5 seconds for thinking. Objective or subjective? Well, as usual, this is a tricky question because it is both objective and subjective. It is objective because it reflects the reality. In the real world, I have these features: my age, my height, my weight. So it reflects the reality, but it is also subjective because I choose what features to use. I choose the scales of my features, feature values, of my feature values. Yes. So the object is much more complex than my model, but still my model reflects the reality. So this is what we are doing. We are building our model, okay, to reflect our objects. Okay, and if our objects are texts, what shall we do? We will see a little bit later. Well, so now my main problem is how to calculate similarity. And for this, I will do something with what I call the vector space model. So it is vector. Why? Because I converted all my objects into vectors. So now they are numbers. So I converted very complex objects in much more simpler vectors, which are numbers. But these vectors correspond to the reality. And so any vectors, well, it is vector. Why it is space? Because vectors have their geometric interpretation, right? So vectors have their geometric interpretation. For example, here we have, well, 3 objects, D1, Q, and D2, right? And as I told before, my main problem is how to calculate the similarity of these objects. The most used method is probably cosine similarity. So my objects are points in a space. Well, we know now it is model because we're modeling. It is vector because we converted the objects into vectors. And it is space because we can geometrically interpret our vectors. So in this case, we have just 2 dimensions. So our vectors, all 3, here we have 3 vectors. They have 2 dimensions. So dimension, let's say 1, dimension 2. So these are coordinates in dimension 1 of this vector, and also this vector will have its coordinate here. And so they also have their coordinates for dimension 1. And what is the idea of this cosine similarity? The idea is that I will take into account the angle between the vectors. The idea is that if the vectors go more or less into the same direction, they are similar. If they go into different directions, they are very different. And if the angle between them is 90 degrees, then they are orthogonal, and it means they are absolutely different. So their similarity will be 0. So this measure has several interesting properties. Well, it starts from 0 to 1, right? And how to calculate it? Well, the formula is very simple. So the dot here, it's just dot product. Dot product is I will multiply the corresponding values of 2 vectors. This similarity is applied for 2 vectors. So if I have 3 vectors, I should calculate it 3 times. Obviously, it is symmetrical, okay? So I just multiply first value of vector A by the first value of the vector B, and then I summarize. So this is dot product. And what is here, it is called Euclidean normalization or L2 normalization. Okay, and it is nothing more than the length of this vector. And the length of this vector is, well, we can see here the triangle. So it is, surprise, surprise, theorem of Pythagoras. So we need to know this. So we have this value, we have this value. So it's square root of the, well, you know. So this is the formula, and it works really good, and you can apply it to any vectors. The other is the Euclidean distance. Well, in fact, if you use Euclidean distance, I would suggest certain, well, to be careful. Yes, you should be careful. Why? Because Euclidean distance in its traditional sense does not imply normalization. Here we divide by the length of the vector, and here we divide by the length of the other vector. If we apply traditional formula of Euclidean distance, we don't. So the vectors can be can go to the same direction, but if their lengths are very different, then the Euclidean distance can be high. Well, you should consider it for any in any your particular situation. For example, the Euclidean distance here is this distance. The Euclidean distance here, it's this distance. Well, very intuitive, right? Distance. So, and also here we have, surprise, surprise, theorem of Pythagoras. Here we have the triangle, and we want to calculate this value. So we have this value, we have this value. So this value is the difference between this and this. So this value is the difference between this, and we need this. So the formula is quite obvious. So, but I suggest that if you will apply Euclidean distance, probably you can consider normalization before. Okay, and in this case, it would be equivalent to cosine similarity. If you will not consider the normalization, then you can have these situations, and yes, I guess Euclidean distance can be not so good. Okay, so couple of words about machine learning. So you already know what are these arrows, these red arrows, orange arrows. What are they? Well, they are vector space models. So if you see this in any machine learning book, textbook, you will find these arrows. Well, and now you know that these arrows are vector space model. And here you have objects represented as dots in this vector space model. Now you have circles and you have squares. So, and what is the problem then? The problem is that the new object arrives. Suppose it is here. So, and we shall classify it. That is, we shall decide, is it more similar to circles or is it more similar to squares? So how to decide it? For this, we use all these machine learning algorithms that I already mentioned. And what are these algorithms used for? Well, they are used for finding the hyperplane. In this case, it's just a line. In case of 2 dimensions, hyperplane is just a line. In case of 3 dimensions, here in case of, it would be a plane in 3 dimensions. In 4 dimensions, it would be a hyperplane. So how to separate my classes? What for? If a new object arrives, where it will appear? To the left or to the right of my hyperplane? So the main problem of machine learning is how to find this separation, how to find this hyperplane. And all these machine learning algorithms do this. They define this hyperplane. And there are 2 types of machine learning: classification, which is supervised, when we know beforehand that circles are circles and squares are squares, and unsupervised, when all objects are alike. So no one mentioned this object is circle and this object is square. So they are all just the same class of objects. So our first step would be, we will mark them somehow and say, these are circles, these are squares. And then we will separate them again. So in unsupervised machine learning, we should first identify our objects, and then we can consider it as if it were supervised machine learning. Okay, so classification is supervised, clustering is unsupervised. Okay, and now, now we will mention several concepts from natural language processing. So the first idea is stop words. Stop words. Well, really very awful term, stop words, but it is widely used. You should know what is this. So stop words are auxiliary words or grammar words, right? Like prepositions, auxiliary verbs, conjunctions, all this, articles. So they are called stop words. For some tasks, you should remove them. For some tasks, you can leave them. So it depends on the task. Usually, if your task is related with lexical meaning, then you should remove stop words. Okay. And here we have the famous SIP law. It is a very interesting law. It is empirical law, So just we know it because it shows itself. So if we will take, what is the formulation of the SIP law? If we take any text in any language, interestingly in any language, we will calculate the frequencies of the words and we will order them according to their frequency. We will get the curve like this, hyperbolic, right? So we will get this curve. Here we have this curve, well, which is like a dinosaur, which has its tail, it has its head. So if we take sufficiently long text, the stop words will be here, right? They have very high frequency, stop words. But if your text is not sufficiently long, it is not guaranteed. Yes, so you cannot just suppose that you will always have here stop words. Besides, there can be some meaningful words. For example, if your text is about something in particular, this word will also appear in the head of this distribution. Okay. Okay, so now you know one concept: stop words, auxiliary words, grammar words. If you translate it into Spanish, I would suggest palabras auxiliares. No inventar algo como, do not invent something like palabras de paro or something. Just auxiliary, palabras auxiliares. Or palabras gramaticales. In general, the term is very strange, okay? Okay, but the idea is that we will ignore these words in case we are doing some specific processing. Okay. Now we come to texts. So we know already, if we want to compare our objects, we want to choose features. So what features shall we choose if we will work with texts? Well, the most common solution is that we will use words as features, words. So we will just separate the text in words, and they will be our features. This model is called bag of words model. Bag of words model. Well, it is very commonly used. And it works pretty well for many tasks. So the other idea is to choose n-grams of words or n-grams of characters. Well, I will talk about it a little bit later. So here, for example, we have a matrix which is called term document matrix. When I say term, I mean feature. So feature document matrix, but the common term is term document matrix, feature document matrix. So these are documents, these are terms, and in this case, these are my vectors. So my vector has this value here, have this value here, and so they are all alike. You cannot use one vector space for one document and the other vector space for the other document. What shall we do if a word is not present in our document, but is present in the other documents? Well, we cannot compare or what? Well, usually I would wait and answer, but now I will answer myself. There is no problem. We just assign 0 to this feature. Okay, so no problem. And we can calculate feature values. They are the feature values, and we can apply cosine similarity, no problem. So about feature values, I will talk a little bit later. Okay, so here is example. How can I translate my texts? Here I have 2 texts. How can I translate them into feature vectors? So my features will be, my name is Juan Luis Ponce Ponce. So these are my features. Ponce just once, sorry. And then I will translate them into vectors. So here my is part, name is here, Juan is here, 0, 0, Luis and Ponce are absent. And my name is Luis Ponce Ponce. Here we have value 2 for Ponce, right? So I have now vectors, and I can compare them using Cosine Similarity, or applying to them some machine learning algorithms, no problem. Okay, so I can do some transformations for my words. Well, and in general, we can consider it as transformation for texts. It is called preprocessing. So for example, I can convert my words into lowercase. I can accompany it with some part of speech tags, grammar categories, for example, noun phrase, okay, or something else. And the other option is to use Engrams. Well, traditional Engrams is something very simple. Well, my name is John is my sentence, and just I have sequence my name. Name is, now that there is intersection, right? My name is John. So these are bigrams. And trigrams would be my name is John. So these are traditional concepts, the concept of traditional Engrams. So, and what is the recommended value of n if I'm working with Engrams of words? Well, maybe the answer is not so intuitive, but it turns out if I use high values of n, the repetitions of Engrams will be 0. So this sequence is present in my text, but it will be absent in any other text. So sequences more than 5 very rarely appear. So you should consider bigrams, trigrams, 4grams, 5grams, but more values of n, no issue, okay? So these are traditional Engrams. Well, since I have no time, I will just mention the concept of syntactic Engrams. We shall build first the syntactic tree, okay? And then we will follow the path of this tree. So we will not take the neighbors as they appear on the surface of our text. We will take them following the paths in our tree. Okay, well, I guess my time is nearly over. I will need some, I think, 5 minutes more to finish. Well, main ideas. If you are interested, you can read my book. All of this is there in the first part of this book. It is really very small book.
I'm sorry, Gregory, just to let you know that you have until 14 hours this talk, so you can keep talking and if you need more time.
Okay, so some more time. Okay, great. Okay, so before we talked about Engrams of words. Interestingly, there can be Engrams of characters. For example, my name is John. We can extract bigrams of characters. So my Y space N, NA from here, and so on. Interestingly, Engrams of characters are very powerful features. So who knows why, but they are. The possible explanation is that they capture the lexical meaning and they also capture some grammatical features. So, well, not very convincing, but this is the explanation, okay? So you can use words, you can use Engrams of words, you can use Engrams of characters. Especially useful, we can consider trigrams of characters, trigrams. So if you want to compare your results, always compare with bag of words and compare with trigrams of characters. Okay, so now about feature values. Well, we mentioned that we can use term frequency as our feature value. What is the intuition? That the frequent words are important. So the frequency is important. The other possibility is just existence. We will use 0 or 1, just once. So we can choose any option. Note that these frequencies can be used for words, and these frequencies can be applied also to engrams. So engram, my name, can appear several times in the text, so it will have certain frequency, say 3 or 4 or something. So when we speak about term frequency, it is the famous TF, term frequency. It's just frequency of my feature, TF. And the other possibility is inverse document frequency. So now we should think about this. We have a document collection. We want to distinguish our documents in this collection. For example, for information retrieval. Yes. If we have our collection of documents, a new query comes. So what documents are relevant? If a query contains some common word which is repeated in all documents in my collection, is this feature, if this word is useful? And it turns out that no, because it doesn't allow us to distinguish between our objects, between our documents. Because all of them have this feature, okay? And this is what IDF is, how distinguishing is the feature. And for this, well, it is inverse document frequency, inverse. So there should be direct document frequency. So direct document frequency shows in what documents this feature is present at least once. Well, when I say at least once, it is also empirical consideration. It can be at least 5 times, at least 10 times. But empirically, we know that if at least once it is present, we should count this. And we took the inverse of this value, and here n is the number of documents in our collection, and it gives us IDF value, which is also very simple. And we took the logarithmic here. And finally, we take the combination. We multiply the values of TF and IDF, and this gives us the famous TF-IDF measure. Okay. Note that if we took logarithm for IDF, we can also take logarithm with TF. The only consideration is that we should add 1 in this case. If we want to take logarithm of TF, we should take logarithm of TF plus 1. Why? Because there are many situations that TF is 0, logarithm of 0 is not defined. So, well, if we add 1, it's precisely what we expect. Logarithm of 1 is 0. Okay, so we just multiply them in logarithmic manner, and we have the famous TF-IDF value, which we can use as our feature value. Okay. And now let us see what we can do if we want to apply machine learning in natural language processing. So what is the general processing scheme? So first of all, we shall formulate our problem as a classification problem. Yes, so maybe it's trivial. Usually it's trivial, but sometimes it is not so trivial. For example, if I want to classify, well, if I want to automatically detect spam and not spam. So I have 2 classes. So this is classification problem. When a new text comes, I shall see if it is more similar to texts of spam or texts of non-spam. So similarity. Okay, so yes, in this case, very simple. 2 classes and it is clear. For example, for word sense disambiguation, how can I formulate it as a classification problem? So first of all, the words can have different senses. For example, the word bank can be financial institute or a place where to sit or a bank of the river. Okay. So at least 3 values. So what shall I do? What shall I classify? Well, it turns out that I shall classify the contexts, not the word itself. The word itself has 3 senses and there is no way to decide which of the 3 we use. But the context should be similar to one of these 3 senses. So my classes will be my senses, and in this sense, it is word specific. So for each word, I have different classes. So for each word, I should perform separate training. And what shall I classify? I shall classify the contexts in these senses. Okay, so yes, it is not difficult, but we should understand it. Another example, authorship attribution. Authorship attribution. So what shall I do? So I have texts written by one author. I have texts written by another author. So how shall I classify? What shall I classify? My classes are the authors. Yes, my classes are the authors. So when a new text arrives, I shall know if it is author 1 or if it is author 2. Okay. Just a moment, sir. I'm sorry. Okay. So the first thing is to formulate the problem. So the other thing is to prepare the data for this problem. So for example, for authorship attribution, if we know the authors, it's enough. For spam, we should know. We are speaking about supervised machine learning. So someone should mark, this is spam, this is not spam. So, and we will have the corpus. Corpus is just a set of texts marked for our task. So the marking is different for different problems, okay? Okay, so the next step will be mark the corpus according to the problem. Well, certainly you should use some other people to mark the corpus, because because if you will do it yourself, you can just make the decisions according to the algorithm you are proposing, and it is not fair. Okay? So then you should perform some reprocessing with your corpus, and probably filter some optional, well, this is optional step. You can filter some elements. For example, you can filter stop words. If your task is information retrieval, yes, you can filter stop words. If your task is authorship attribution, probably you will leave stop words and will filter out all the rest. Well, there were works when they consider 8 grams of stop words, 8 grams of stop words. These were the features, and they filtered out all the rest, and they classified pretty good. Okay. So now you have your corpus, it is marked, and now you can select the features and select the feature values. So as feature values, you will use TF usually, or TF-IDF. And it is precisely the construction of vector space model. Okay, and about the features, well, you know, you should try bag of words model. You try character engrams, for example, character trigrams. You try various word engrams. By the way, if you consider words, bigrams of words, trigrams of words, and forgrams of words, well, you can consider them separately, but once more empirically, it turns out that combination of these features works better than all of them separately. Yes. So also consider the union of these features. Okay. Then the next step will be to filter the features. For example, you can ignore the features which has frequency of 1. It means that they appear just once in your corpus, so they are useless. Or, well, it depends. Or you can say, I will use the 1000 most frequent features. It is possible also. Many tasks it was done. 1000 most frequent features. Okay, so somehow you can filter your features. Then an optional step, apply, well, they say dimensionality reduction, latent semantic analysis, or principal component analysis. So you have vector space model in many dimensions, and you can, oh, and you remember, in fact, it is a term document, and you can apply some matrix operations. So LCA and PCA, it's not more than applying singular value decomposition. So, and you have new vector space model. It's not just I filter out some features, I have new vector space model, which is more correspondent to the data. So when you perform this, you have new vector space model, which in theory is better. In theory is better. So does it mean that I should always do it? Well, theory says yes, practice says, well, it depends. Well, you should always try this step, always try to apply dimensionality reduction, but it doesn't mean that you will get better results. So you should try it and compare it with the process without dimensionality reduction and to choose which is better. When you choose dimensionality reduction, you should choose the number of dimensions, the new dimensions. So they say that there is practically a magic number of 500, but you should also try 2, 3, 4, 10, 20, 50, 100, 200, so on. So empirical science. So you should try various parameters. And when you finish with it, either you have new vector space or you have your original vector space. Now you apply the classification algorithms and you perform the experiments and you evaluate your results. Yes, it seems that now you're happy, but no, you have your results. But to be happy, you should compare your results, because are your results good or not? It depends on the performance of the other algorithms. And you should always compare with two things, with very foolish, very simple baseline algorithms. For example, if I have classification in two classes, what would be my baseline? Well, just random classification, for example, random classification. So, and I will have accuracy of 50% with random classification. So if my very sophisticated algorithm obtains 40%, well, probably it should be improved. Yes. And the other is applying my method to state-of-the-art, comparing my method with state-of-the-art methods. Yes. And if my performance is better than state-of-the-art, then yes, I can write a paper and say, look, my features with my dimensionality reduction and with my classifiers are better than state-of-the-art. So yes, so this is better method. All of this is traditional machine learning applied to natural language processing. So now I hope that you more or less understand what is happening. So formulate the problem, prepare the data, construct vector space model, apply classification algorithms, and finally compare the results. So this is the general procedure. Okay. So there are some other ideas related with deep learning. Well, I will mention them, well, at least just the first one. For example, this, you shall know a word by the company it keeps. It was said by a linguist, John Firth, about 70 years ago. And this is just the basis of all machine learning algorithms applied to deep learning algorithms, right? they all are building their representation, word embeddings, based on the context. So how similar are their contexts, okay? So the most famous probably is word2vec. Well, we want to predict word in the context, we want to predict the context of the word. And we train a neural network. So the idea is simple, which is good. The implementation is difficult, of course, yes. So now that word2vec is both the resource, so we have a vector with 300 dimensions for each word, yes. And the good thing of this vector is if I will use bag of words model, my matrix will be very sparse. There will be a lot of zeros. And this vector for word representation, well, practically it never has zero values, okay? There are similar resources and algorithms. It is also algorithm for training. It is a resource and it is also an algorithm. So you can train your own algorithms. And certainly the modern techniques, transformers, which is application of attention mechanism. Yes. So this is just example. Well, Alexander already spoke about it, that the word sad is near the words tragic, green, crying, yes, which is quite intuitive. So the word walk is near the words move, walked, hang, okay, quite intuitive. Well, some properties of word2vec in GenSim library. So we can apply mathematical operations over vectors. We can see we said similarity is our principal operation. So we can see word2vec similarity with the word car, the word minivan is the most similar, and the word communism is the less similar. And by the way, all this is due to the context analysis, okay? Okay, well, this is another example that the word similar to word father are the words mother, brother, and sister. And we can easily apply it, applying GenSim library. And probably the final idea, it's transformer, and it is attention mechanism, okay? So we have practically the same phrase. So here we have tired, and here we have wide. So the animal didn't cross the street because it was too tired, and it refers to animal. And here the animal didn't cross the street because it was too wide. This it refers to the street, okay? So, and we have different attentions, and it is really amazing that this attention to animal and this attention to street are quite different, because wide and tired affected the attention mechanism. So it is really very impressive, and you should learn it in other tutorials. Well, some just here, syntactic engram. So likes John, likes Apple, like. Well, so I recommend you to use syntactic engrams. Once again, the theory says that it should be better than traditional engrams, but in practice, it is not always better. Okay, the problem probably also is that we should apply some parsing procedures if we want to obtain syntactic engrams. And I think it would be all. Thank you for your attention. So if we have some time, we can answer all the questions.
Thank you very much, Professor Sidorov. Well, we have some questions. Most of them have been already answered by Professor Gelbuch in the chat. So there are some people asking for a research stay, or how can they come to the CIC, to the Center for Computing Research, to meet you, or if can you give them your contact? I guess your email is also in your webpage.
Okay. So this wasn't the question, right? Oh, yes.
Well, if they can contact you through your webpage, if there is an email
Yes, there
address
is
or something, contact.
my email address. Yes, correct.
Okay,
Yes,
thank
there
you
is a
very much.
question.
And yeah, there is a question about GPT-2. If in your lab, have you used or explored GPT-2? And what do you think about its future and its applications?
Well, we didn't apply yet GPT-2. We are applying BERT and the various versions of BERT, which is conceptually the same thing, I guess. But no, GPT-2, no. But yes, I guess that we should try. We should try. For now, we're using BERT because for GPT-2 we need more resources and there are certain limitations. Okay.
Yeah, of course. And there are some questions through YouTube that maybe they have not been able to read the answers in the chat. Is David Celaya Herrera. He says, how can NLP transform the marketing research or research in general? Do you think it can transform it?
So marketing research. Well, yes. Well, as Professor Gelbuch already mentioned, well, you probably also noted it, that the advertisements, the announcements you get by email or while you are watching your YouTube files, they are personalized. So they are for you specifically. They are based on your history. So now we know that they can also use your profile in Facebook, your messages probably. They have access to your data. So they are, yes, they are very personalized now.
Yeah, the examples shown by
wants to add something.
Would you like to add something, Professor Gelbuch?
Sorry, I did not understand.
So if marketing will be influenced by NLP research.
Moment. I have a problem with moment.
Technical problems.
Could you please repeat the question?
If marketing will be influenced by NLP research.
Marketing influenced. Okay, I see two aspects here. Probably Grigory already mentioned it. First, for personalized recommendations, they need to understand a lot of things about us, not only what we filled in the Facebook profile. Because there we could fill in very specific things like age or gender. But there is a lot more to understand about us. This can be extracted from what we publish in the form of text. And second, to convince us, they can show us images or just suggest goods to buy, but they also can accompany it with messages, with text messages. And these messages can be crafted to better convince the buyer. In addition, okay, look, we are speaking now about advertising, just those advertising messages that Grigory mentioned. But there is much more about it. We can study market situations by studying the context in social networks. For example, in our lab, we did research on predicting the price of actions of companies, or predicting the exchange rate of dollar by reading tweets, reading what people say in social networks. This understanding, this information would also influence marketing, not in that sense, not in the sense of showing advertisement, but in the sense of investing in this or that company, for example, where the flow of investments will go can depend on what we understand from what people say. Dixie.
Okay, thank you, Professor. We have another question from YouTube, and it is examples. Can you give some examples of language models? No, sorry. There are examples of language models that include simple bag of word models, latent direct allocations, and word-to-vec. So which language model is best in order to explore suicidal ideation?
In order to explore what?
Suicidal ideation, suicide.
Well, Gregory, yes.
Well, you should try. So your question was about what language models. Well, you should try various language models, and this is precisely the object of our study. Which language model is better for this specific task? So we perform experiments, and empirically we know that, for example, for suicidal detection, we should use, I don't know what. Yes, well, I expect that in this case, neural models would perform better. For example, several years ago, we published a paper that for depression detection, the combination of unigrams, bigrams, trigrams, and 4 grams of words is, well, quite good. Well, it turns out that it was the best combination, better than, for example, character trigrams. Probably at the current stage of research, I expect that some BERT-like model would perform better for this task.
I would say just pick the most modern model that you can handle in your hardware. If you can handle GPT-2, just start from it. If not, start from BERT.
And they say you should perform fine-tuning for your data. Yes, so you use pre-trained BERT, you fine-tune it for your data, and you're happy forever.
Thank you very much. Indirectly, you answered the question from Robert Morales about bigrams and trigrams, because he asks if they always improve accuracy and similarity. I would like just to pose a last question, if there is time for that, about links between natural language processing and research in psycholinguistics.
First of all, I would like to add about bigrams, trigrams. No, once again, you should perform experiments. So empirically, we know that combination of unigrams, bigrams, trigrams, and 4 grams of words performs better than all of them separately. But also, once again, it is not guaranteed. So maybe your task is more specific and it will not be so. In general, there is a, well, they say a theorem of no free lunch. That is, there is no universal model and no universal algorithm, which is always the best one. So it depends on your data. So you should perform experiments.
I would say it depends on data sparseness. If you have sufficient data, a lot of data, then most probably bigrams and trigrams and 4, 5, 10 would improve performance. If you have sufficient data. What?
10 grams, no. 10 grams of words.
If you have sufficient data.
No.
But usually we don't have sufficient data. Usually we don't have sufficient data even for bigrams. So it depends. If you have a lot of data, try bigrams, trigrams. I mean, you can expect improvement. If you don't have enough data, then most probably it will not work.
Okay, and about psycholinguistics, well, we should try. If you mean by psycholinguistics study of emotions, then yes, this is a quite traditional natural language processing problem, study of emotions in texts. If you mean some specific psycholinguistic experiments, well, then probably no. But we can discuss it. If you have some ideas, you can write us and we can discuss it.
I can add that we did such research. Please, Elena, don't eliminate still the question. I will give a link. So we did such research on detecting big 5 traits from statuses in Facebook. I mean, from short texts, you already can see the psychological traits of the author, and of course from longer texts much better. I will now type a reference to our research in this on Big 5, there where the question is. Yes, I will now type the reference.
Yes.
Well, I think we are over time.
Mm-hmm.
So thank you all
Yes.
very much.
Thank
And
you.
I don't know, Elena, if you want to say something before we close.
Yes, before you close, this was a very interesting question about psycholinguistics and NLP. We had also a paper where we use some psycholinguistics research like word association norms to generate embeddings. This is a new kind of word embeddings from word association norms. So we typically use these resources from psycholinguistics as resources for doing NLP. So you can check some of the papers in this area also. This is all. Thank you, Iram.
Okay, so just a last word. Please visit the site I have just written in the chat, ampln.org, which is the site of our organization, which has organized this summer school. And you can find there our contacts. So please feel free to send emails to all of us. We will be very happy to answer all of these questions. We are happy to see all this curiosity from you. So never think any question is too basic, because we are here all to learn. So please write to us. And thank you very much for attending this session. Please keep enjoying all the talks. And as Professor Gelbuk said at the beginning, please don't forget to see all of our keynote speakers, because, well, everything I think is very good for all of you. Thank you very much.
Thank you very much, Grigory and Alexander, for this wonderful talk. This was very interesting. You have also some comments in the YouTube streaming. For example, Fernanda Aguilar says, "Thank you. I really enjoyed your talk." So thank you very much.
Thank you.
Thank you for all the attendance. See you tomorrow.
See you. Goodbye.
Thank you. See you.
Bye.
Goodbye.